All right, so today what we're going to do is we are going to begin our look at what are called pictograms. Remember, this whole section, the whole chapter in 19 is all about different graphs and charts, ways to visually depict information. And a pictogram is a really good way of doing that because they're often very, very clear. What we're going to do is we're going to determine how we can make sure that the information presented is clear and what makes a good pictogram and what kind of data is good using pictograms. So all you're going to do with a pictogram is you're simply going to be using a picture, a picture. How about we get rid of one of those? A picture to represent an item or number of items. Okay, so just using a picture to represent an item or a number of items. So for example, if you were measuring how many donuts that were eaten in a certain day or sold at a certain shop, then you might use a donut. But lots of donuts are sold, so you wouldn't want to use one donut to represent one donut. You could use a picture of one donut to represent 100 donuts, for example. And that's fine as long as you provide a key, all right? So you must have a key to tell us. Otherwise, you don't need a key if it's one picture equals one item. But if it's more than that, you have to have a key. So in that example, you might have 3 donuts, and each picture of a donut represents 100 donuts. You might have 3.5 pictures of a donut. So that 1/2 would represent 50 donuts in that case, right? So you can have whole pictures, half pictures, and sometimes quarters or thirds, but it gets a little fuzzy with pictograms unless it's something that's really easy to see. If you have a donut, that's pretty easy to do a fourth of a donut, right? Because a circle can be divided into four equal parts pretty easily. But other times, don't get too creative with those. Just change your scale. So for example, let's say you have 25 items in one group, 10 items in another group, and 7 items in another group. You wouldn't want to say that they're all worth 10, right? Because the 25 would be fairly easy. The 10 would definitely be easy. You'd only get 1. But 7 would be hard to represent that using something that one picture represents 10, right? So you might use 5 and then just have to try to draw the best you can. So having said that, you can also see some of the limitations of pictograms. It's difficult if you use a part of an object to represent a number that doesn't easily divide in half, etc. All right? So what we're going to do is we're going to look at how to draw a pictogram, and how to read them, and as well as some limitations and how to fix them. Okay? So let's just pop over to the book and look at some examples. So here we go. In this example, it's talking about having a pictogram using a symbol of fruit. So you have different fruits under cultivation, and you see that they give you the numbers of cultivation. So they've simply used the actual picture of each fruit to represent the number of hectares there. Now, if you look at the scale here, there were 30 hectares of pineapples, 5 of guava. So they just chose the smallest number and used that. It said that one picture is going to represent that smallest number, which in this case is 5. Okay? So when you see the 6 pineapple there, that's really, each pineapple represents 5 hectares, right? So that's really 6 times 5 would represent 30 hectares. Okay? Now, and again, pictograms generally use the actual picture of the object that you're measuring. Make sense? Yeah. Pretty easy, good. And notice here at the bottom, each of the symbols represents 5 hectares. You must have a key, again, unless each one represents just 1. Okay, so you see how very easily it is to represent them. Let's look at this example, however. Right? This pictogram shows the number of pizzas consumed by 4 different people in a month. And what they did was, instead of using more pizzas, they just made the pizzas bigger if the person ate more pizzas. But if you look at that, for example, with the Aaron with 7 pizzas, can you easily see that big pizza represents 7?
Yeah.
No way. There's no way to see that that's 7. How? Right? You're crazy. All the pictures are the same. So they're not. Well, but so does the one with 4, and so does the one with 2, and so does the one with 1, right? So what they want you to do is describe why this is not a good pictogram. So using a different size picture for each thing is not a good idea. What you need to do is you need to use a picture that represents a certain number of items and then repeat that.
It's not a very good example because we don't really know.
Yeah, exactly. So we can't tell the difference between between 1 pizza, 2 pizzas, 7 pizzas, etc. Yeah, good. So what we're going to do is we're going to see how to fix this. So to draw a better representation using this pictogram, instead of saying that 1 big pizza is 7 and 1 little one is 1, we'll just use 1 drawing so that 1 pizza equals 1 pizza. And then just list them out. Now we could use a key and do something different here, but 7 pizzas and 1 pizza. We could use 1 pizza equals 2 pizzas, right? And then because it's 7 and 1, we could cut them in half. But we don't need to in this case because pizzas are easy to draw. They're basically just circles with dots on them, right? So let's look at their solution. The pictogram gives a poor and distorted representation because it's not easy to see by the size of each picture how it represents the number eaten, right? But to fix it, you could simply use a different number of pizzas that are all the same size. So there's the piece I want you to take out of this. Don't use the size of the picture to represent the number of items. It's the number of drawings that you use, okay? So what we would do then, instead of that, we could simply say that Corey had 1 pizza, and you could draw a better pizza than me. Brandon had 2. You don't have to put them in order, but it doesn't hurt, right? So you're just drawing the same picture for all of them. So Adam had 4, and Aaron, I don't know why they gave me 2, had 7. Right? But they should be all the same size and all the same drawing for all of them. Okay? Put some toppings on it, and then it'll look more like a pizza. But...
Oh, that looks really faster.
There you go. All right. Now, grow up. All right. So, super simple. Just draw the best drawings you can. Nobody is going to judge you by your drawings, but get the right number of them and put a key. What would my key be on that one? 1 pizza equals 1 pizza. All right. So you see, here we go. There's their drawing with the fancy ones. Okay? Now, shh. Here we have a table doing ice cream sales. What do you think they might use for ice cream sales? Ice cream cones. But since we have 90, 35, 5, and 55, you're probably not going to do 1 equals 1. You'd have to draw 90 of them. You could do 5, but 90 would require a lot of them, wouldn't it? So 10 might be easier here, right? Shh, gentlemen. So there you go. There it is with 10. And notice they said half of 1 equals 5. If you have a full cone equals 10 and you have a half a cone, you can pretty much assume that half of it equals 5. Okay, so you get the idea?
Yes.
All right. Then you have some homework. Your homework is simply to do number 1 and number 3 on this.
So
One of them, you're just going to be drawing a pictogram, and then the other one, you are going to be correcting a pictogram. Now remember, if you're measuring all the same things, then draw the same picture, right? If it's all coconuts, then draw all coconuts. Don't draw something else just for everybody changes. There you go.